Okay, I'm going to wrap up number 13 that we started in class, and then I'm going to do 14, and then I'll show you on the homework what I want you to do. So we have our roots, and we're trying to get back to the original polynomial function. And we remember that if we have r as a root, x minus r is a factor. So my goal is to take each of these roots and write it in the form x minus r. So the 0 would be x minus 0, which really I don't need the minus 0, it's still just x. So I'm just going to write the first one as x, and that's coming from the root of 0. And then I have x minus 3, and then I have x minus I. But then if I have a positive I, I also have a negative I, so then that would be x plus I. And I'm going to start by multiplying these together, and I'll probably go and distribute this as well. So here I get x squared minus 3x. And then when I get these two multiplied into a new polynomial, I'm going to do the same thing over here with the complex conjugates. And then I'll multiply the two binomials together. So here when I multiply first times first, I get x squared. My outer is a positive ix and my inner is a negative ix. So I don't even need to multiply those, they cancel. And my last term is a negative I squared. A negative I squared is really a negative 1, making it a positive 1. And we talked about in class today that if you set that equal to 0 to solve, you would actually get the roots of I and negative I. So now I'm going to multiply. Let me use some color coding here. I'm going to do x squared times x squared and x squared times 1. And then I'm also going to do negative 3x times x squared, negative 3x times 1. So you can still do it the way that I did it up here, basically, where you have your first here, your outer, your inner, and your last. That's just another way of doing it. You can do it either way. So when I multiply all this out, I get x squared times x squared, which is x to the 4th. Then I need to do 1 times x squared. So that's just going to be x squared. And I'll rearrange these in a minute. And then I get a minus 3x cubed. And then I get a negative 3x times 1 is negative 3x. So it's not in standard form because these two terms are reversed. So I'm just going to say the polynomial function is x to the 4th minus 3x cubed, because you want to go down by degree, plus x squared minus 3x. And that would be the answer to number 13. Now, number 14, we have negative 4 and then 1 plus 2i. Which means we also have a 1 minus 2i. We talked about this in class. A plus bi has a complex conjugate partner, 1 minus bi. So I changed the sign of the I, essentially. So negative 4 has a factor of x plus 4. So this would be x minus r. So x minus a negative 4 gives us this x plus 4. Here I have x minus 1 plus 2i, and this is just more complicated, so I'm going to set it up like this. X minus r here, and the r is 1 minus 2i. So I need to distribute this negative, so I'm going to do that next. So x minus 1 minus 2i is going to get multiplied by x minus 1 plus 2i. And then I have the x plus 4. So I'm going to multiply my complex conjugates together first and get another polynomial to multiply by the x plus 4. This is a time when I would definitely suggest maybe doing like some sort of table form for multiplying. It's x minus 1 minus 2i, x minus 1, and then a plus 2i. And then I need 3 columns and I need 3 rows because it's a 3 times a 3. All right, so when I go to the first cell, I go up and over, I get x squared. Go to the next cell, I get a negative x. The next cell, up and over, gives me a negative 2ix. It looks weird, but something's going to cancel with that in just a second. Go to this cell, up and over, negative x. Here I get a positive 1. Here I get a positive 2i. And then here I get a positive 2ix. Here I get a negative 2i. And here I get a minus 4i squared, which is really going to be a plus 4, so I'll go ahead and change that. Now, we see some things canceling out. The 2ix and the negative 2ix cancel, and that's what's supposed to happen. And the 2i and the negative 2i cancel. So let's put this back together. So I have x squared here, and then I can combine the negative x and negative x to give me a negative 2x here and here, and then I have the 1 and the 4 that add together to give me 5. And then here I have x plus 4. Okay, so again, you could kind of use the rainbow effect here, but I'm just going to kind of multiply x by all of these and then 4 by all of these. So x times x squared is x cubed. X times a negative 2x is negative 2x squared, and x times 5 is 5x. Now I'm going to use a method here where you kind of line things up by like terms. So when I do 4 times x squared, I get 4x squared. And then 4 times a negative 2x is negative 8x. 4 times positive 5 is positive 20. Now I have everything lined up, so I can just add. I'm combining like terms here, so I get x cubed. Here I get positive 4x squared. Here I get a minus 3x. And then I get a plus 20. And this would be the polynomial function there. All right, so there's the answer to that one. All right, so let's go to the homework that I handed out in class. And if you are absent today, I'm sending it out as an attachment to this. And it was this worksheet here. So I'm going to do a couple of these with you and then let you finish it for homework. So they start off pretty simple. 3 is a root, then x minus 3 is a factor. Negative 5 is a root, then x plus 5 is a factor. And this is one that you can just first times first, outer, inner, last. So my polynomial function is going to be x squared. Here I get a 5x. Minus 3x gives me 2x, and then a minus 15. And this is something you could have factored to get it back to this form that you could have solved for these roots there. Okay, number 2. We know that the 0 was a GCF factor of x. And then I have x minus 2, and I have x minus 4. Now you can do this a couple of ways. I could distribute the x into one of these and then multiply the product times the second one. That's what I'm going to do. So x times x is x squared minus 2x, and then this gets multiplied by x minus 4. And again, it's a binomial times a binomial, so I can just do my first terms, x cubed. My outer term is minus 4x squared. Oh, sorry, yeah, that's right, minus 4x squared. And then I have minus 2x squared, which I can combine that in a minute. And then here I get a plus 8x. So when I write it out in standard form, x cubed minus 6x squared plus 8x. And that would be the answer to number 2. Okay, I feel like number 3 is similar enough that you can do that on your own. Number 4, let's look at that. So I have a negative 1, meaning the factor was x plus 1. I have a plus and minus square root of 2. So x minus the square root of 2, x plus the square root of 2. And I'm going to always multiply these first because the outer and inner terms are going to cancel with each other. So x times x is x squared. This would be a positive 2 square root of 2x. This would be a negative square root of 2 times x, so they would cancel. And then I have a negative square root of 2 times the square root of 2 is actually 2, because it would be the square root of 4, but it simplifies down to 2. And think through, if you had this binomial that you're solving, you would set it equal to 0, add the 2 over, and square root. So you get back to those roots right there. And then I have x plus 1. So then again, x times x squared is x cubed. So I did this one. Then I'm going to do the 1 times x squared. That gives me x squared. Then I have a minus 2x here to here. And then I have a minus 2. And this would be the function for that one. Okay, let's look at number 5 because it is a little bit different. And for number 5, I just wanted to show you this one thing. We did this in class today, but just making sure everybody sees how to do this. I have x that goes with the 0. And remember how we said we're going to start with x minus 3/2. And x, this would change signs because it's x minus the negative 1/2. And then remember how I told you you're just going to take this denominator and you're going to pull it up. You're going to take this denominator and pull it up. And then you're done. You're ready to get started. So x, and then I have 2x minus 3. So I just took the denominator and pulled it up. And then I have 2x plus 1. And then think through, I'll just kind of take this off to the side. If I had this as a factor and I was trying to solve it, I would subtract 1, and then I would divide by 2, and I would get this negative 1/2. So see how this root matches this factor. So that's how you're going to do it when you have a fraction. Now from that point, I feel confident you can multiply all that out. And I do want to look at one more, which is this one right here, number 7. So for number 7, I have x minus 2 as the factor. And then I have x minus I square roots of 3. And then x plus I square roots of 3. So I have both the positive and negative this. And again, I'm going to multiply these conjugates together first. I get x squared. The outer is a positive I times the square root of 3, and the inner is a negative I times the square root of 3 times x as well. So those cancel, okay? So I'll write that out. I square roots of 3 times x, which typically you put the x there. And then the inner is going to be a negative I times x square roots of 3. So they cancel each other out. The last term, though, is going to be a negative because it's a negative I times a positive I. So negative I times I is I squared. And then square root of 3 times the square root of 3 is the square root of 9, which is 3. Okay, so it's going to be a 3. So to simplify this out, x squared, and then that's going to be plus 3. Because this is a negative 1. So negative times negative is positive. 1 times 3 is 3. And if you think about it, if you set this equal to 0 to solve, you would end up with a negative 3 that you're trying to square root. So there's your I. So plus minus I square roots of 3. So those roots match back to this factor. And then you would multiply that by x minus 2. And again, I feel confident you can set that one up for yourself or finish multiplying that out. So I want you to finish this worksheet for homework. We've set up probably almost half of them already, so please finish that so you don't get behind. We'll be working on the review some more on Monday, and then we're learning to do some word problems with this as well. So make sure you're caught up by Monday, and have a great weekend.